Hey everyone, thank you so much for joining us. Welcome to the Hasura community call. This month's community call is really special because it's our 10th community call. And so again, thank you so much for joining us. It's a very special call for us. And I'm Vish. I'll be hosting the community calls from now on. We'll be missing Marion's very sweet presence, but so you might recall me from the previous community call, and yeah. So let's get started without further ado. This month's agenda is super special, as I said, and so Tanmai will be presenting the Hasura update, and Auke will be giving us MySQL support, and yeah, we have a few other things lined up. So Tanmai is here. Tanmai, please take it away.
Hey everybody, let me just get my screen share set up. All right. And let me enable video as well. All right. Okay, so I will be giving you all a quick update on the different things that are happening inside Hasura and inside the Hasura product. And so we'll talk a little bit about that. So one of the first things is that we're moving, that we'll also gradually be shifting over to GitHub discussions. We'll be using that alongside our Discord as well. As a lot of you might be familiar with, we've been having, there's lots of times when people have similar questions, and that knowledge and information about a particular playbook, a particular pattern, a particular solution is kind of lost in the void. And so it'll be nice to have that on GitHub discussion so that we'll be able to share stuff and whatnot, and we'll be able to use that. We'll be able to use that easily. Just a second, let me move where I'm sitting from so that we don't have less background noise. So, work from home reality. All right. Okay, cool. And then I'll be talking about a bunch of other things that are happening, new features, and a few changes, just setting the stage up for a few other conversations that we'll be having today over the call. So three super cool features: remote schema permissions, multiple roles, and Postgres functions as custom mutations. Let me talk about each of them super quickly. Remote schema permissions, our aim is to get to a stage where we have full role-based schema masking. So you can have a role, and then for that role, you can choose exactly what subset of the schema you want to expose and have preset arguments as opposed to present arguments. So let's change that to preset arguments. Present arguments are always better than absent arguments. But, and so we'll have preset arguments for that. So that you can define for any particular role, when a particular query or mutation is called, you can choose to enforce a particular value, right? A particular value of the argument. And at the same time, you can also choose what subset you want to, of the schema you want to expose. This sounds easy to do, and the initial version is actually fairly simple. There are some hidden complexities when it comes to handling interfaces and enums and union types in the way that kind of role-based schema masking would work. The nice thing is that we have a good we have a good spec for it now. For multiple roles as well, we've been having several discussions, and now what we'll be able to do is automatically compose. Is to be able to use multiple roles simultaneously. Today, you can have multiple roles, but per query or per mutation, you have to specify a single role that you want to use. The idea will be to have that as to have a combination of roles, and then be able to kind of use a combination of roles in the single query or mutation. And there's some interesting problems that we've spec'd out here and that we solved around being able to automatically compose a correct schema, so that when you make an introspection query, you get the right kind of composed schema automatically across those roles, right? Being able to merge results, so that if you have multiple rows, duplicate rows being returned by duplicate roles, and they're kind of merged properly, so that the multiple roles abstraction makes sense. And the third thing, which has been something that people have asked for a long time, is Postgres is having volatile Postgres functions or stored procedures. and being able to expose them dynamically as mutations or even as queries. And so here the interesting thing to work out was permissions and relationships and how to infer that so that your volatile functions can return both table types, but also return scalars. And so these are things that you should see in the next release or two. And these should land and these should enable a bunch of use cases, or if you have any workarounds for these in place already, you can remove those workarounds and kind of simplify your Hasura setup. The next piece, which is a fairly big change to the product internally, is this idea of making the database addition, when you add a database to Hasura, making that dynamic. And what I mean by that is if you look at if you look at the current architecture today, Hasura to start requires a database URL, right? So you provide a database URL and then Hasura starts up. Instead of that, what we'll do is Hasura can always, run, and you'll always be able to load the console, and then you can add the database dynamically, or you can remove it dynamically, right? Just like remote schemas. And so databases just become like another remote schema. And so this is nice for one database, but this is also nice when you have kind of multiple databases. And a few folks will be talking about that over the rest of the community call. The super nice thing is that this is entirely backwards compatible. And so although this is a huge change, if your existing Hasura setup will not have to change at all. It will remain exactly the way it was. And if you want to kind of move to this feature, you'll easily be able to toggle it on and off on your Hasura setup. So that change will be fairly easy. Another thing that we're doing here as a part of this is also making the environment variables that we have, a bunch of those environment variables, also a part of metadata configuration, so that these can also be configured, dynamically, which will be cool. And that's and that'll be that'll work well. And specifically on the templating side, we have templating for environment variables with action URLs, but that hasn't extended to other things, other parts of the metadata. So that will soon come to other parts of the metadata as well. And that will make a bunch of things simpler and easier too. Cool. All right. Let's move on to the next piece. These use cases are things that people are going to talk about. The way kind of closely related to this idea of making databases dynamic, or additions of databases dynamic, is this idea of also separating and having dedicated storage for metadata. So the current Hasura architecture is that what it does is when Hasura runs, it stores its own metadata, right? The metadata that says, these are the tables, these are the relationships, these are the permissions. It stores that metadata in the same database that you're using. Right? And the way this changes is that metadata can now be inside a separate database. And that's neat, because that enables a bunch of things like blue green deployments or zero downtime rollouts, or even having multiple Hasuras pointing to the same Postgres. A bunch of those kinds of use cases very easy. And again, the theme is that nothing changes for your existing setup, so it's backwards compatible. And so you don't have to worry about it if you don't need separated metadata storage. And like I said, what this will enable is a few kind of more advanced deployment use cases, or kind of iterations that you're making on your Hasura setup, especially with like having a V1 URL and a V2 URL, and having them both kind of simultaneously on the same database, which will be very, very kind of useful and interesting for making big changes or releasing big changes. All right, the third piece here. And this is something that we've been working on closely with some of our customers, especially in enterprise. If you have a use case where you're kind of looking at, moving from one database to another for a variety of reasons, especially if that one database is, say, you're moving from a Postgres or MySQL or SQL Server to another separate Postgres or MySQL or SQL Server, do get in touch with us. And Hasura's kind of GraphQL API specified trigger setup would really kind of help in that migration. And so please feel free to reach out to me on email or Discord or Twitter, and we'll get in touch with your team and see if there's something that we can help you with. And this is going to be a very interesting use case for us. And there's one of the slightly harder problems, especially if you have an existing application, you want to have a more modern setup or a more modern database. Sometimes even when you're migrating from a Postgres to, say, something like a Yugabyte, or if you're moving from MySQL to PlanetScale or something, right, where you are kind of migrating data, right, to a different database, even though it's very similar, it is still a migration process. All right. The other thing that I want to highlight was that I recently wrote up a small blog post. It's not a small blog, large blog post called "How Hasura Works," which is a bit of a misnomer. It's not a perfect title. It's more of a how Hasura thinks, or a design philosophy of how Hasura is built. Please do check it out, and if you have questions, again, please do feel free to get in touch with me. And any feedback that you have would be super useful. So those are the updates from my side. There are a few questions on chat, and I'll keep responding to them on chat. But we can continue with the rest of the call.
Awesome. Thank you so much, Tanmai. That was a very exciting update. As Tanmai said, he'll be on the chat. So if you have any questions for him, you can ask them there. Moving on. Sorry, let me just share my screen first. Moving on, we have Auke's MySQL support. So Auke, please take it away.
That's my cue. Yes, so I'm Auke. I'm a backend engineer at Hasura, and I want to talk about an experiment that we've been doing over the last months, let's say. Let me share my screen. And it's called, very cryptically called Project Dolphin. And it's about adding MySQL support to Hasura. And of course, this is a monumental undertaking. And so kind of what we've done is we've released this preview release of MySQL support, which is certainly not ready for production, but the purpose is to get this stuff in your hands as quickly as possible so that we can get your feedback and improve this as quickly as possible. And so so the background is that we had this Series B funding release, and as part of that we made a kind of a sprint towards getting some kind of MySQL support in Hasura. And if you want to play with this, well, it's already there. If you click on this link, you get to the docs, and in the docs there's some directions on how to start using that, and it uses Docker Compose to get it up and running quickly. So if you have Docker and you have Docker Compose, then you can do that. And since it needs to download a few things, I'll get that started while I do my presentation. So here I have the Docker file, Docker Compose file, there it is. And then I can simply type Docker Compose up, and then it will hopefully start downloading that and eventually running that. Now, one thing I should note here is that, in fact, I modified the Docker Compose file a little bit because in the Docker Compose file, you have to set your MySQL host, username, password, etc. And I don't have an existing MySQL server, so I added a third Docker container into this Docker Compose file so that I kind of get a MySQL server included. Right, so what did we do? So previously, what Hasura did is you have a Postgres server all the way on the right, and you have some clients connecting on the left, and Hasura is the thing in the middle, right? Clients connect through Hasura and fetch data from one Postgres database. So if I say that we want to, just add MySQL support, you might imagine that, the new version would look something like this, where instead of Postgres, we would simply have MySQL. But for kind of engineering technical reasons and for reasons that Tanmai already hinted at as well, what we did instead is we have two databases. So the preview release has both a Postgres database built in, which is where we store the metadata, and we have a MySQL database that we can connect to. And kind of the bigger picture that we have for this is that really what we want Hasura to be able to do is to pull data from a number of sources, and maybe this is another Hasura instance, maybe this is a SQL server, and that's stuff that we're working on right now. And so, being able to have a mixture of database sources and a mixture of remote sources, that's stuff that we're working on and that will be released in the next months. Right, and now I hope that the demo made some progress. Seems to be making progress. That's good. My timing is impeccable. Right, so it started Hasura GraphQL engine. And what you see here is the usual console. And if I go to data, you see that we can add, for instance, tables. But now I have to note that here, this console is Postgres only. We didn't change the console. And so the only thing that, the only way in which you can see that MySQL is added is by the console automatically loading in tables from MySQL. And currently we started with an empty database, so there's nothing. But if I would create a table through the console, so maybe I call it test, then you see that it can create a table. And now in the console over here, you can see that we can query to it. And if I had some data in there, maybe I add some entry Auke, then sure enough, it's there. But this is all in Postgres. So now how do we get MySQL data into here? So it has already connected to the MySQL database. What we have to do is actually load some data into the database. And so what I can do is, for instance, load up the Chinook database, the demo database called Chinook. And so let me just dump the Chinook database into the MySQL container. Okay, so that's done. Now, if you go to the console, it hasn't changed anything because it only rereads the MySQL database when there's a metadata event, so to say. And currently, there are no events for MySQL management at all because this is only a backend thing, not connected through the console. So you have to jiggle it. You have to give it a little kick. And one thing you can do is, well, you can just create a new Postgres table, for instance, where you can reload the metadata. So if I reload the metadata, that's one way to give the small kick. And then if we go to the GraphQL tab, you see that it has all of these tables now loaded. So of course I can still query the Postgres, but I can also now query, for instance, the MySQL database. So there you go, that works. So we can query the MySQL database, and even the relationships work. So here you go, here's a relationship. What does not work is mixing Postgres and MySQL at the moment. So if I would try to query both my MySQL table and the MySQL table over here and the Postgres table over there, then we would get an error message because this is simply not supported in our preview release right now. This is something that we are definitely working on, and that's coming up soon. Yeah, I think that's it. That's the demo. As I said, if you want to play with this, if you go to the funding announcement blog post, then under point 4, there's a link to the docs, and there you can get all of these files that I have using. Any questions?
Okay.
Case,
if you have any questions for Auke, Auke would be happy to take them in the chat. Next up, we have Rikin to present his demo on how to run multiple Hasura instances on a single Postgres database. So, Rikin.
Hey, so yeah, I think I'll get started with that. Okay, I'm going to start by sharing the screen.
Sure.
Cool. Okay, I hope that's come up now. So yeah, in a sense, this is what's happening here. So we have now the capability of serving multiple GraphQL APIs on top of a single common database that we have, right? So how this kind of works is that we can have a Hasura, which can have its own metadata Postgres database, in which it will store its own metadata, and we can have multiple versions of these, which can connect to a common database, which will hold the data, right? So this allows us to kind of build APIs for separate applications, which are using the same data on the same database, right? So I'll just show a quick demo of how this works. So what I have here is I'll just quickly take you through the setup that I have here. So I have this Docker Compose file, which is setting up my database for the data. So I have this service called Postgres data, which is storing all my data, and so this is the schema that I have on this particular data, which is our old friendly Chinook database. So now what I'm going to do is I'm going to set up 2 Hasura instances which will connect to the same database here, but give out a different API, for the, different use case, for apps for different use cases. So I have the the database with the data set up here, and I have this Docker Compose file, which is setting up my GraphQL engines. So as you can see, I have this GraphQL engine 1, which is a service which connects to its own metadata Postgres here, right? And for the configuration, you can see it. I can pass something called a metadata database URL, which is the the database that I have set up on this Docker Compose. And then I have something called the actual, the database URL, which is the database will have the data in it, right? So what I can do is just, run this. Right. And what we should see is GraphQL engine, set up here. And what I'm going to do is also I'm going to run another, GraphQL engine, which is a very similar setup. I've just changed the names of the services here, right? And as you can see, they connect to the same, Postgres data database here for the data, right? So I'm just going to run this. And it all looks good here. We have 2 versions of GraphQL engine running, and cool. So what I'm going to do is also, run a graphical instance using GraphQL so that you can explore the API that we have. As we see here, we have a query route, but there's no fields in it, right? So yeah, so currently the metadata, there's no metadata which has been applied on the Hasura instance. So what we can do is I have this, metadata, which is kind of exported earlier from again, we have the, oops, right. So we have, cool. So this is just a metadata version that I had exported earlier. And I have a similar one, which I'm calling the public one, right? So as you can see, the metadata here has data of the album, the tracks, and the artists, right? While the internal metadata has data regarding customers, employees that, we have and stuff like that. So I'm just going to quickly go and apply this metadata. So as you can see, I'm applying this on the first Hasura that we had set up, and we have success. And I'm going to apply a different version of the metadata on the second Hasura that I've set up here, and we see success here for that as well. So now if I can go back here and refresh, you can see this is the first Hasura that I had, and now I have these types in my schema which I can now query. As you can see, you can just see the albums, the artists, and the genre related information, the track related information, and I can query this and we get the data. And we can also run another graphical instance connected to the second GraphQL instance that we have, and yeah, we see the data related to the customers, the employees, and other stuff which we could use to build a backend app, the internal app for the thing we have, and we see the data is being served, right? So yeah, so this is my demo. So the essence of how this all works is like I had said, right? So each Hasura now kind of has its own metadata database it connects to, and then it has a possibility to connect to multiple other data sources as such, which could be currently it's Postgres, and like Auke had demonstrated, we can connect to MySQL as well. So yeah, that's what my demo.
Awesome. Thank you so much, Rikin. That was a great demo. Next up, we have Aleksandra with her demo on one Hasura, multiple Postgres.
Hi, let me share my screen. Okay, I hope you can all see my screen. So I'm basically going to show something like the opposite of what Rikin was showing. So like multiple Postgres instances and one Hasura instance. So this is a console, and previously we had this left sidebar, and we were only able to choose a schema. now we are also able to choose database. And right now I only have one, my default data database. And there's also this manage databases section, and I can go there to add more instances if I want. So I can click this add database button and choose the type, Postgres. So right now we only support Postgres, then we will support MySQL and other databases. I will add some name like first DB and connection string, which is Postgres. And I could also set some settings, like connection settings, like max connections, connection idle timeout, and retries. But we can go with defaults right now. I can click save, and my data source was successfully added. I can then click this on this icon to see this connection string if I want. And maybe we can also add another one. I will copy paste this connection string because it will be similar this time. And I will add another Postgres instance. And now if I go back here, I can see that I can choose from all those Postgres databases that I have. So let's say I will choose this first DB. I already had some tables there, so I can just drag them as usual to see if everything works. Yeah, I also had some relationships, so can track them as well. Then I can do the same with my second database, and yeah, and everything is working like within those databases as before. I can also check in GraphQL and see that I have access to the tables from all the data sources, like post and user is from my first database, and those test table 1 and test table 2 are from my second Postgres instance. So yeah, so I guess this is what I wanted to show. I basically wanted to show how it looks like here and how you can manage those databases in the console. Thank you.
Thank you so much, Aleksandra. Next up, we have Tiru with his demo on running Hasura on a read-only Postgres database.
Hey folks, just give me 1 second because I have to proxy this video call with Google Meet because Zoom does not run on Linux. You can quote me on that.
Lies.
No.
I had to go through a great deal of stuff to make this work before the call.
So wow, you're running on Hangouts and then screen sharing that with the Zoom or something.
Yes. I did that action in action some time ago.
Hey, but I thought Zoom used to work on Linux. Go ahead.
Okay. So I need to share screen at 2 places. Okay, I'm really bad at this. Give me 1 second. Here we go. Okay, so can you folks see my screen here with the terminal? Yes. Mm-hmm. Oh, okay, awesome. So the demo here is going to be like how to use the metadata separation architecture that you saw so far to kind of make Hasura run on some kind of a limited Postgres instance. Like it could be a completely read-only Postgres instance, like a read replica, or something which is running in backup mode because of some kind of a log recovery or so on. But it could also be running Hasura with a database user who has like very few privileges. Like maybe the database user can only read from few tables. And so far, there was no way for you to run Hasura over that, because there has to be a metadata store, right? And so that means there are like write permissions which are involved in making Hasura run over an existing Postgres database. But let's see what will happen now, right? So I have my terminal here, and if we look at Docker, I don't have any containers running, so I'll quickly run a Postgres container. So that's just starting Postgres on port 6432. There you go. So I want to run Hasura over this database, right? So before I do that, let me just show you some SQLs that I'm going to execute to A, populate a table, and B, I will also create a user who's like very less privileged. Like so you can see the three commands, just three commands that I'll use to create the user. The first is just create user with this password. The second is usage on schema, which you require to do anything on that schema. And the third, which is the most relevant part here, which is that it only has select privileges on the public schema, right? So let me quickly go and create that. So I already exported this, so I can just import the script. There you go. So I have created these things. That means I have this user, which means that if I now run my Hasura service on this Postgres instance, and I can do that using Docker, and I've already set up the database URL to match this user, which is Hasura user and Hasura user. And the GraphQL engine version, as you can see, is the latest version, which is 1.3.2. So what will happen if we do this? I don't see my service here. That means it might have exited, as it shows here. So let me do Docker logs, right? So it will give me a permission denied for database Postgres, and it could not, and it got this error while trying to execute this create schema statement, right? So as expected, Hasura did not start with this Hasura user, database user, right? So what can happen next? As you can imagine, we can actually separate the metadata storage to a completely different Postgres, maybe spawn a new Postgres instance with for just the metadata part, which you can control and have like more access to. So I'm going to do that now. So I have this another Docker service command, which is going to start Postgres now in port 7432. The previous one was in 6432. And I will first spawn this. So now I have two Postgres instances, one in 6432 rather than 7432. And I will also run my Hasura with this preview build, which is what will be released shortly as version 1.4. And the important bit to see here is that I'm giving two URLs now, two environment variables. The first one is called metadata database URL, which is pointing to ports, which is pointing to the Postgres service, which is running on 7432. And this is the default admin password, right? Postgres password. And the other database URL is my regular database URL, which was the Hasura user on the database at port 6432, right? So I'm going to run this now. So this runs successfully. Let's confirm that. So it says that the server has started, which means that if I have a thing running here, a local console running here, and there you go. So Hasura is starting. I can see the table that I created before, so I can track it as well. And if I come back here, I have my query here, and if I run it, I can run it as well. So I ran Hasura with almost like a minimal privileged user, a user who could only do selects on a table. And this kind of gives you a sense of like what all things you can do with the Postgres user, right? And the Postgres database to which you are pointing Hasura to. It could be a read replica. You could point it with a very different user, and so on and so forth. So that was the first. Yes, actually that was my demo. I have another thing coming up after Gavin's demo. So yeah. So thanks, Vish.
Okay, awesome. Thank you so much for your demo, Tiru. That was a wonderful demo. Gavin also has a really cool demo coming up. But before that, just to make this community call a bit special, since it's our 10th community call, we wanted to click a picture with everyone. So if you're comfortable coming on and sharing your video, that would be great. And let's have a picture. Cool, I see faces. This is wonderful. Hey everyone, thank you so much for joining us. Hey, I'm gonna have to click a few pictures because we have so many people here. So I'll have to actually change the slides. This is so nice. Few more people in the second one. Awesome. Thank you so much, everyone. Cheers. Next up, we have Gavin to present his demo on blue-green GraphQL deployments with Hasura. Take it away, Gavin.
All right. Share screen. Okay. Can you guys see?
Yes, that was such a cool wallpaper.
All right. Thank you. This is going to be probably kind of an underwhelming demo following Rikin, because basically what I'm going to show you is exactly the same thing, just applied to a situation. So the idea here, right, is that you have some web server, in this scenario it's Caddy, and I have basically two services. I have a blue and a green. And each of these has their own Hasura instance, and there's a shared Postgres, but they have their own copies of metadata, pretty identical to the set we saw. And then this is just processing them to the two containers that I have. And yeah, so if you look at these two, let me go to the permissions tab, and let me minimize this. Okay. So there's different roles. So this is the green on the left and the blue on the right. And so I have like unique roles defined for each of these, and then a role that's the same between them. But the permissions are actually a little bit different on these. And so the way that I can demonstrate that is here I have Hasura role as shared role, and the same here as shared role. And when I query this, I'm able to query for the aggregate and both ID and something. And when I query using the same role on the other instance, the only data that I'm able to pull back is something, and I don't have access to the aggregates. And yeah, so I could go through like an entire CI CD step where you do like a blue-green deployment, or one of these servers is your canary. But generally the use cases that you might be able to imagine are that, hey, I have some data table or whatever that's shared between multiple instances, and I want to verify some changes that I make before I deploy them to my master instance, or I want to do a gradual rollout and catch issues as they arise in production. So that's pretty much my demo.
Perfect. Awesome. Thank you so much. Now we have Tiru again for zero downtime Hasura upgrades. Welcome back, Tiru.
Hey, hi. Yeah, I think I'll do better this time. in my response time sharing. Here you go. Okay. All right. So, okay. So this is a presentation because this is a very, very intricate topic, and we'll see why. So zero time upgrade basically means that you are moving from Hasura version, say 1.3 to version 1.4, and you want to do this in a way that none of your requests are kind of timing out or giving 500s during the rollout process. So what's the issue today? Like, why are upgrades not zero downtime today? That is in version 1.3 and below. So the quick version is that they are mostly zero downtime already. Like if you do a rolling deployment, what you can do is that you can keep the older version running. You spawn a new version with the newer Hasura tag, and then once it's fully up and running, you kind of shut down the older replica, right? And these kind of things can be automated with almost every container management system and so on. So it's already zero downtime, except there are a few edge cases, right? The edge case comes when Hasura's internal metadata catalog. So we talked a lot about the metadata storage and so on. That's also a specific schema, like internal system catalog for Hasura. And that could also change across these upgrades, right? So if you kind of have used Hasura a lot or read the logs during the startup, you might see something like this log message, which says successfully migrated from catalog version 35 to 37, something like that. Sometimes you see annoying errors here where for some reason you cannot migrate catalog or downgrade catalog or so. So this is the startup process, which kind of takes care of making migrations to Hasura system tables, not your user migrations, but the Hasura internal metadata tables. So the old replica may not be able to understand a new catalog, new metadata catalog, especially during these rollout processes, because the newer version would have upgraded the metadata schema, right? So in that brief period, like maybe 30 seconds where this rollout process is happening, a service may not be serviced properly because maybe that request itself is something like reload metadata, or it's a DDL operation, or there is a schema refresh for some reason, and it has to go and read the new metadata tables. So this is the edge case that we want to solve for zero downtime deployments. And with Hasura Cloud and the new metadata storage architecture, we can actually do it. The whole system has been thought about from this perspective a lot. And the biggest value here is that Hasura Cloud itself can store the metadata and manage that for you, so that you don't have to worry about these kind of zero downtime aspects of deployment. So what does the architecture look like? So if you upgrade Hasura to say version 1.4, and later down the road you want to upgrade to version 1.5, both of them are pointing to the same metadata store, right? And they're changing the metadata table. So what the two things that we'll take care of when these kind of metadata upgrades happen is that the new version is kind of in a no catalog change mode, right? So it does not do, although it is running, it can service requests, but it actually did not, from a catalog perspective, it's still running on the older version. So that as soon as the older replica is actually shut down, you can toggle this catalog change mode to like active mode, where it will go ahead and change the catalog after that. So that now it can run with the newer catalog tables, and there are no instances which are relying on the older catalog system, right? So both Hasura versions can run together in with this kind of a mode of catalog change, right? And the second thing that we'll make sure of doing is that whenever we are writing to these internal catalog tables, and one of the biggest challenges is there is an event trigger mechanism which is continuously writing to one catalog table. And we have to make sure that when there are two Hasura versions, especially during this rollout period, you are still able to consistently function, like the event triggers are being delivered or created smoothly, and there are no drops in terms of like delivery, and there are no unnecessary retries and so on. So what we will do is make sure that the main payload which gets stored in the metadata tables is kind of versioned in a both forward and backward compatible way. So these are a lot of internal details, but the short answer is that you can now get zero downtime deployments without having to think about these smaller issues, these edge cases which can pop up at the worst time, and it will be very hard for you to like know if a service for what reason was a request throwing 500 and so on. And with Hasura Cloud and the built-in metadata storage, this will make the whole experience versionless in some sense, that you would get the latest and the greatest without having to worry about this metadata management. And you can do the exact same thing that we will be doing in Hasura Cloud yourself also with if you're self-hosting this or using the OSS engine, and that would enable you to experience zero downtime as well. So yeah, that was the main idea behind what zero downtime means post version 1.4 with metadata storage separate. Thank you, Vish.
Awesome. Thank you so much for that update, Tiru. That was very insightful, and congratulations on successfully sharing your screen. That was great.
Yes.
Next up, we have, community updates from me. Let's go. Let me just share my screen. I'll be very quick so that we have enough time for our awesome community demo. We have a bunch of really cool community events coming up, and one of them is, this is super exciting, one of them is Enterprise GraphQL Conference, which is a one-day free virtual conference that we are organizing in the month of October. And it will be on, the conference will be held on 22nd of October, and the theme is unlocking data for developers. So let me quickly show you the website. Yeah, the website is live. And as I said, the theme is unlocking data for developers. We have some really cool speakers who will be sharing their experiences. We have speakers from Optum, from Tesla, Shopify, SAP, and Hasura, of course, Uber, Airbnb. So it's going to be a great agenda. The rest of the agenda is going to go live next week, so stay tuned for that. Marion will be sharing the website link in the chat. Now, before the conference, we also have two pre-conference events. One of them is the Hasura workshop on building an enterprise-grade data access layer with GraphQL and Hasura. So that's a really exciting topic. And the other is Hasura Hackathon. Of course, super excited for this. The hackathon has started, but the important part to note is that it's going to go on until 19th of October. So it's a month-long hackathon. So we'd love to have you join the hackathon. And if there are any projects that you are shelving for the end of the year, and this is going to be a great excuse for you and your team to work on something really cool, an app idea that you have. So yeah, please check that out. Next is, we have a really interesting, very cool webinar coming up on 6th of October on enterprise grade authorization. So keep your eyes peeled for that one. Again, you will find the link in the chat. We also have Hasura office hours now, and that's going to be a live informal chat session with the team. So make sure that if you want to hang out, come hang out with the team, you join the Hasura office hours. Also, another quick update on Hacktoberfest. Personally, super excited for this one because Hasura is joining Hacktoberfest as a participating organization for the 3rd year in a row. And so my teammate and I, Shraddha and I, we just published this super cool blog post for you all to check out. So if you want to get started with open source, and especially open source with Hasura, we've curated a bunch of issues that you all can work on. And yeah, so we're really excited about that. And on that note, we'd also love to hear from you. What kind of swag would you like for Hacktoberfest this year from Hasura, the exclusive swag that you'll be getting? So you'll find the link to this tweet in the chat. So make sure that you vote for your favorite swag. Awesome. So that's all from my side on community events. Now introducing Nikhil, who is our community presenter. So Nikhil from Yugabyte will be presenting their demo on scaling GraphQL workloads with a distributed SQL database. Nikhil, please take it away.
Hey, thanks, Vish. Hey all, my name is Nikhil. Super happy to be here. I work as a lead software engineer for Yugabyte. I work in the drivers and ecosystem team. I'm happy to talk to you guys about how you can scale GraphQL with distributed SQL. Let me quickly share my screen first. Okay. So today, right, like I just wanted to take take you through a short demo of how you can scale like your GraphQL workloads. I can also deploy it on multi-region and how all the resiliency comes into the picture of your database. I mean, obviously Hasura gives you kind of a resiliency already, but what about your database layer itself, right? So we're gonna go through that using Yugabyte DB. For folks who don't know Yugabyte DB is a distributed SQL database. It's an open source project. You can come check us out here. For today's session, all we need to care about is like we are a sharded, like we are a cluster database where we shard our data set into all the available nodes in the cluster. And for a GraphQL or a Hasura perspective, it can connect to any of these nodes and it can talk using a Postgres compliant SQL and query the database itself. So on the top layer, we kind of support Postgres for querying the data. So it's like, I'll show you the setup that I have today. Like probably like sometime back, Hasura had published a white paper where they had like did a benchmark of how to scale their GraphQL subscription workloads to 1 million records, or sorry, million subscriptions. So we wanted to take the same thing and I wanted to see how you can scale the GraphQL layer as well as your database layer linearly, right? So traditionally what happens is in databases, you kind of just scale it vertically, like you cannot scale writes, even with Amazon Aurora and things like that. You can obviously scale reads, but writes is difficult. Sometimes when you have a Hasura and also other workloads adding to the database, you might want to like scale your database layer also. For that, we have like a very simple application, like which is kind of simulating an e-commerce workload. We have user account, which has a bunch of columns in it, and we have user orders where he is probably making an order through e-commerce, and we can simulate orders for each of those users. So what we are going to do today is I'm going to show you in our setup how we scaled a GraphQL subscription like this using Yugabyte DB, where we can scale Hasura layer also linearly, as well as you can scale your database layer also linearly. So this is the setup I have. Like everything is running on Kubernetes. We have a layer of Hasura instances running, which actually works talk to Yugabyte DB for serving the request, right? So first thing I wanted to show you was just how we are deploying Hasura instance on Kubernetes. So this is the only change we will have to do. What I'm doing here is I'm just specifying Kubernetes DNS name for where Yugabyte cluster is running. So if I go back to my, I will go to my console here and I'll show you my setup, what I have. I have a Kubernetes cluster that I am spun up on Google. It's a GKE cluster. I have deployed Yugabyte DB cluster, which is like a 3-node Yugabyte DB cluster I have. So I have those clusters running, and I have I also have like 3 Hasura instances that I have started, which is connecting to that Yugabyte DB cluster. If I go to my console, you can see I have those 2 tables that I had showed you previously, the user account and user orders. I've already tracked it so that it has some data in it, and we can go ahead and query the data. like it will give you the results and things like that. So for this demo, I'm gonna just make it as a subscription so that whenever I start loading the data, you can see a new subscription coming up. Okay, cool. As part of that demo, I mean the setup itself, like we have one more thing. We have like a subscription app, which is based on that same subscription benchmark tool that Hasura guys had put out, like Hasura folks had put out. So we are using the same thing. I just made few changes so that it can run natively on Kubernetes as a Docker container. So we are just reusing the same thing. I'm going to just show you the setup I have for benchmarking tool itself. So if you see here, this is my benchmark configuration. I'm saying I'm starting like 25,000 subscriptions, and I'll start this subscriber so that it can start making subscription against Hasura, and Hasura can keep a lookout for the data whenever the new data comes up, right? Now, what I'll do is I'll go ahead and start a sample data loading app, which is going to go and load the data into orders. So as and when the new orders come in, so we'll see that data come in the subscription. Obviously, like in this workload, you see, right, like the situations when there is like massive scaling you need during holiday seasons like this, during the Black Friday season, you can not only scale your Hasura linearly on Kubernetes, you can have your database layer also. You can go ahead and do that. So let me tail the logs for this so that we can see the data going in. Okay, perfect. The data started writing. I can go and check the data getting written in my console also. This console is like it's a Yugabyte DB console, which it's like an admin console where you can go and check the metrics of your cluster, what's happening on the cluster and things like that. If you see, based on my subscription, what I had already scheduled, that there's like few selects happening to retrieve the subscribers. So, and now since I'm doing starting a new transaction, like all those subscribers will continue to like get the subscription. And one thing that I could do is like I could go and do edit the cluster and increase the number of servers. So I don't have to change anything on the Hasura side, because if you notice, I was giving Hasura DNS, like in the I was giving a DNS name for Yugabyte servers, so that Hasura doesn't need to rebound, or it will automatically like load balance the load across all the available nodes. So this kind of shows you how easily you can scale not only your Hasura workload, but also you can scale your database layer itself on Kubernetes. Like this kind of fits into that cloud native model of yours. Basically, pretty much based on your workload, you can scale linearly. Cool. That's all I had for this. Like if you are interested in it, like you can go to our GitHub repo, and we have we are going to write a blog post on this basically based on the GraphQL, like how Hasura had scaled 1 million. We are going to just write a similar blog where how Yugabyte could scale it linearly using Hasura.
Awesome. Thank you so much, Nikhil. That was a great demo. Also, it would be great if you could share any of your social handles or anything, so that if folks want to get in touch with you, if they have any questions, they can reach out to you.
Sure
You
thing.
can drop in the chat.
Do that.
Awesome. All right, folks. So thank you so much for joining us for this community call. All of you contributed to making it super special, and we're also very thankful for our community presenter this time. Thank you so much for joining us, Nikhil. That was a great demo. We're always trying to improve and make our community call better. So if you have any feedback that you would want to let us know, if there's anything, any way that we can improve our call, please leave your feedback through our community call feedback form. You can find the link in the chat, or you can take the screenshot of this slide to make sure that you can come back to it later. Also, if you would like to present a community demo like Nikhil did in this call, if there's something, really cool that you build, and if you want to showcase your project or your contribution, then we'd love to have you in one of the upcoming community calls. So please feel free to reach out to us through our community call demo form. Again, link will be in the chat. And finally, the next community call, you can save the date. It is going to happen on 29th of October at 9 a.m. PT, same time. And we'd love to have you. Thank you so much for joining us.
Bye, everyone.
Bye,
Bye, everyone.
Have a good day.